Let's take a look at solving simultaneous equations. So I've got a scenario here where someone is buying 3 cups of coffee and 1 cup of tea, and in total they've spent £1.70. So I want to find out how much 1 cup of coffee costs, and I want to find out how much 1 cup of tea costs. Well, we could approach this using trial and error. So at a guess, let's say that 1 cup of coffee was 20p. So 3 cups of coffee would be 60p, and so 1 cup of tea would be £1.10. That is a solution to this setup here. But I could also spend 30p on 1 cup of coffee, and then 1 cup of tea would have to be 80p. Now that still works, but as you can see, I have got a different set of solutions to this problem. So there's lots and lots of different possibilities right now for the price of 1 cup of coffee and the price of 1 cup of tea. I don't know exactly the price of either of them. But say a second person walks in and now buys 2 cups of coffee, and they buy 1 cup of tea as well. Except this time their total will obviously be different. This time they've only spent £1.40. So if coffee was 10p, then a cup of tea must be £1.20. But if tea is £1.20, then I would have 50p left over in the first scenario, and 3 cups of coffee costing 50p is not the same as 1 cup of coffee costing 10p, because, well, obviously this coffee up here is going to cost more. Except that can't be true. The coffee must cost the same in both cases. So there must be one definite set of solutions for these two cases. Let's try and write this down in a simpler, more mathematical form. So let's say 3c plus t is equal to, let's say, 170p. And then 2c plus 1t equals 140. So you can see that I've used c for coffee and t for tea. Well, let's think about what we've got here. We've got 3 cups of coffee in the first case and 1 cup of tea, 2 cups of coffee and 1 cup of tea in the second case. So what's different and what's the same between these two scenarios? Well, in both cases I've bought a cup of tea, and in both cases I have bought 2 cups of coffee. There are 2 cups of coffee inside these 3 cups in the first scenario, so the difference between the two is 1 cup of coffee. And so the difference in the price must also be 1 cup of coffee. So what I can do is I can subtract one of these equations from the other to find what is different between the two and find the difference in the price. So if I was to do that, well, 3 cups of coffee take away 2 would leave me with 1 cup. The cups of tea are the same in both, so t minus t is just nothing. And then the difference between the price is 30p. So I've worked out that a cup of coffee must be 30p. And this is how we approach solving simultaneous equations. We can use this method here to subtract one from the other to eliminate one of the variables. So this is called the elimination method. And once I've worked out the price of 1 cup of coffee, I can put it back into one of my previous equations. So 3 times 30p plus a cup of tea is equal to 170. Well, that will be 90 plus t equals 170. And so t is, let's subtract 90 from both sides here. So t is going to be 80p. So hopefully you followed that all the way through. And now I want to have a look at a slightly harder one. So we're not talking about cups of tea and coffee now. Let's just use x's and y's. That's what we're familiar with. So 2x plus 3y equals 13. X plus y equals 6. So I've set it up here with the x's on top of the x's, the y's on top of the y's, and the numbers all lined up. This is going to help me later on. And I'm going to number my equation. I'm going to call this equation 1. I'm going to call this equation 2. So right now, if I was to find the difference between these two equations, well, I'd have a difference of 1x and a difference of 2y. That doesn't really help me very much. That is still 2 letters that I don't know equaling a number, and that's really hard to work out. I need to eliminate one of these letters in order to work out the other one. So the way to do that is to transform one of these equations to have the same coefficient, which is the number in front of the letters, to have one of the letters' coefficient be the same as the first equation. So I can multiply this second equation here by 2. So I'm going to multiply this whole thing, both the left-hand side and the right-hand side, by 2. So equation 3 is going to be equation 2 times by 2. So on the left I will have x times 2, which is 2x, y times 2, which is 2y, and on the right-hand side 6 times 2, which is 12. So I've multiplied everything in equation 2 by 2 to get equation 3. And now let's have a look at equation 1 and 3. So we can see that the x's, we have the same number of x's in both of these now, and the only thing that's different between the two of them is the y's. So if I just get rid of this middle line, we can compare these two a bit better. Well, let's do what we did before. Let's subtract them from each other. So left-hand side, we've got 2x minus 2x, which is nothing. 3y minus 2y, which is y. On the right-hand side, 13 minus 12 is 1. So I've worked out what y is. Y must equal 1. Now let's substitute that back into our equations. I could have substituted it back into equation 2, but I've rubbed that out now. So let's just go stick it back into equation 1. So 2x plus 3 times 1 is equal to 13. So that is 2x plus 3 equals 13. Subtract 3 from both sides. That gets me 2x equals 10. Then I can divide both sides by 2. That will get me x is equal to 5. So the solution to these pair of equations, or what was there before, equation 2 as well, the solution to those two, and in fact the solution to this equation 3, they all have the same solution, which is y equals 1 and x equals 5. So you might be thinking, well, why is this the case? Why do I get a pair of solutions for x and y? Well, let's think about what we're dealing with here. We're dealing with equations with x and y in them, and you might have seen before that we can use something that looks like this. So if we rearranged our equations in the previous question and got them into this form, on a set of axes, they would be 2 straight lines, and 2 straight lines are either going to be parallel to each other, so they're either going to never cross each other, or at some point they're going to intersect. They're going to cross over at some point, and that is a point that is true on both of these lines, and that is what a solution to a pair of simultaneous equations is. That is the coordinates of the point where the 2 straight lines cross each other. So let's move on. Let's look at a slightly more complicated question just to finish off. Let's take a look at 5x plus 4y equals 37, 2x plus 3y equals 26. Right, so this time I have got different numbers of x's, different number of y's. So I know I'm going to have to multiply in order to get the number in front, the coefficient of one of these letters, to be the same. But I can't do that to just one equation in this case. I can't just multiply this bottom equation. So the easiest way to do this is to find a number that both of these numbers can be multiplied into. Both this 5 and this 2 can be multiplied, and we can turn them into the same number. So let's call them equation 1 and equation 2 again. So a shared number between 2 and 5, well, the smallest one is going to be 10. I can multiply 5 by 2, and I can multiply 2 by 5. It's like the lowest common multiple if you've done that. So equation 1 I'm going to multiply by 2 to get to equation 3. And so let's do that. That's 2 times 5 is 10x plus 8y equals 74. And then let's multiply equation 2 by 5. And this is going to get me equation 4, which has the same number in front of the x. I've multiplied 2 by 5 here. And so you can see, same number there. I can do something to eliminate those two. So 3 times 5 is 15y. And let's do 26 times 5, which is 130. So now I can subtract 3 and 4 from each other. So I'm doing 3 minus 4. I could do it the other way around, but we'll see it turns out all right in the end. So 10x minus 10x is nothing. 8 minus 15y is going to be minus 7y. And 74 minus 130 is going to be minus 56. So now if I divide both sides by minus 7, I will see that on the right, minus 56 divided by minus 7, two minuses make a positive. That leaves me with positive 8 equals y. And now I can take that and I can substitute it back into one of my previous equations. So 5x plus 4 times 8 equals 37. Let's do this quickly. 5x plus 32 equals 37. Minus 32 from both sides. 5x is equal to 5, so x must be equal to 1. So I found the coordinate of the intersection of these two straight lines. Or you could say you found the solution to this pair of equations. What we've been doing up to now is we have been subtracting equations from each other to eliminate one of the values. Here we subtracted to remove t, and then we've subtracted here again. We've subtracted to remove x here. We've eliminated the 2x, and here we've eliminated the 10x. So we've got rid of 10x in that scenario, and we've subtracted one from the other. Well, what about if we can't subtract these two equations from each other? What about if it's 4x plus y equals 52 and 2x minus y equals 20? Well, here if I subtracted the two equations from each other, if we just thought this through, well, 4x minus 2x would be 2x. And obviously we're trying to eliminate the y here. If we were to do positive y minus negative y, that would be minus minus y, and two minuses make a plus, so it would actually be y plus y if we tried to subtract these two equations from each other, and that doesn't get rid of the y at all. But what about if we added these two equations together? Well, this positive y plus minus y, this plus minus makes a negative here, so it would be y minus y, and we'd eliminate that variable from our equations. So let's add these two together. We'd get 6x is equal to 72. And so dividing by 6 on both sides leaves me with x equals 12. And now I can use this, I can substitute it back into my previous equations. Let's do that. 4 times 12 plus y equals 52. So 48 plus y equals 52. Subtracting 48 from both sides, y equals 4. So the solution to that pair of equations is x equals 12 and y equals 4. So not every time am I going to be subtracting the equations. If the number in front of the letters is the same, here we have 1 in front of the letters. If the number in front, if the coefficient is the same but the signs are different, you can add the two equations together to eliminate that variable. So there you go. That is the elimination method for solving simultaneous equations.